Welcome to our deep dive into the fascinating world of Megaraptora.
Oh, yeah.
You've sent over some great material on these carnivorous dinosaurs, including excerpts from the Megaraptora Wikipedia page, which was
Wow.
just updated this month.
Wow.
Get ready to uncover some mysteries because these creatures have paleontologists debating their place in the Theropod family tree.
Yeah, they really do. It's like trying to solve a puzzle with missing pieces.
Right.
We're constantly learning new things about Megaraptora.
Yeah.
And every discovery adds another layer to the mystery.
So, okay, before we get lost in the family tree,
Okay.
let's start with the basics. What did these Megaraptora actually look like?
Picture this, a medium to large-sized dinosaur with some species reaching lengths of up to 12.8 meters.
Wow.
That's like a school bus with teeth.
Oh, my goodness.
And speaking of teeth, their skulls, based on the fragments we found,
Yeah.
were long and narrow with surprisingly small teeth for a predator of their size.
Wow. That's a bit unexpected. You'd think a massive predator would have equally massive teeth.
Right.
What's the thinking on that?
It's a great question, and it might point to a more specialized diet than we initially thought.
Okay.
Maybe they weren't crunching bones like some of their larger theropod relatives. Their long snouts and smaller teeth could suggest they were adapted for catching smaller, faster prey or even scavenging.
Interesting. So picture a Megaraptoran chasing down its dinner and... Wait, hold on.
Yeah.
Didn't they have these huge claws?
Ah, yes. The claws are what make Megaraptora truly stand out. We're talking about massive curved claws on their hands.
Wow.
So big that they initially confused some paleontologists who thought they belonged on their feet.
Oh my gosh. Can you imagine making that mistake?
Right.
I mean, those claws are practically iconic.
Yeah.
They almost scream, "Look out, here comes a predator."
Yeah.
But if their huge claws were on their hands, what about their arms?
Yeah.
Were they just for show?
Not at all. In fact, Megaraptora had surprisingly well-developed and powerful forelimbs.
Oh.
Unlike many other large theropods where the arms were pretty diminished.
So we've got this image of a long-snouted, fast-running dinosaur with huge claws and strong arms.
Yeah.
It's a bit intimidating.
It is.
I'm already picturing how they might have used those arms and claws to hunt.
You're right on track. A recent study by Rolando Novas and Porphyry
Okay.
actually suggests that those orlimbs weren't just for display. They had complex muscle attachments that would have allowed for a range of movements,
Wow.
possibly even grappling with prey and using those claws to deliver a fatal blow.
Wow. Okay, that definitely adds to the predator image.
Right.
But here's something I find fascinating. You mentioned earlier that their bones were surprisingly lightweight.
Yeah.
Didn't you say they were filled with air?
That's right. We call them pneumatized bones.
Oh.
And they're a feature we see in modern birds as well.
Right.
Think about it. If you're a large, active predator, having a lighter skeleton would be a huge advantage.
It makes sense, especially if you're chasing down prey. It kind of challenges those old images of dinosaurs as lumbering giants.
Exactly. It suggests a level of agility and athleticism that we might not have expected.
Right?
And those air-filled bones might also hint at a more efficient respiratory system.
Okay.
Perhaps even a link to the evolution of bird lungs.
Now that's interesting.
Yeah.
So we're not just talking about lighter bones, but potentially a more bird-like respiratory system. A large predator with a breathing capacity to match its speed. It definitely paints a different picture.
It does, and it raises even more questions about their metabolism,
Right.
their lifestyle, and their evolutionary connections to other theropods, like birds.
Speaking of connections, I know we'll be diving deeper into the whole classification debate later.
Okay.
But can you give us a little preview?
Sure.
Where were these Megaraptora found? Were they just hanging out in one specific spot?
Okay.
Or did they have a wider range?
Here's where it gets really interesting. Megaraptora had a surprisingly wide distribution.
Really?
We've found their remains in Patagonia, Thailand, Japan.
Wow.
And they were especially prevalent in Australia. Imagine these powerful predators roaming across multiple continents.
Wait, Australia?
Yes.
As in home to some of the most unique creatures on the planet, Australia.
The very same. And get this, the largest known Australian predator, Australovenator, was a Megaraptorian.
That's wild. Okay, so now I'm really starting to picture these Megaraptorae as major players in different ecosystems all over the world.
Yeah.
But before we get ahead of ourselves,
Right.
let's take a step back and tackle the big question.
Okay.
Where do they actually fit into the Theropod family tree?
All right.
Are they more closely related to neovenatoroids or tyrannosauroids?
That is the question.
Or maybe something else entirely?
Ooh.
That's what we'll be exploring in part 2 of our deep dive, so make sure you're ready for some serious paleontological detective work.
I can't wait.
All right, so we've got this picture of Megaraptora as these powerful aphel predators with huge claws, long snouts,
Yeah.
and a surprisingly wide geographic distribution.
Right.
But now we're getting to the heart of the mystery, their classification.
Okay.
Where do they fit in the grand scheme of theropod evolution?
That's the million-dollar question. And as you mentioned earlier, there's a lot of debate in the paleontological world.
Yeah,
The evidence seems to point in a couple of different
right.
directions.
It's like a paleontological whodunit. We've
Exactly.
got the suspects, the neovenatoroids and the tyrannosauroids, but the clues are a bit scattered.
Exactly. And like any good detective story, we need to examine the evidence carefully.
Right.
Let's start with the neovenatoroid hypothesis.
Okay.
What makes some researchers think Megaraptora might belong to this group?
Well, I remember you mentioned something about those air-filled bones, the
Yes.
pneumatized bones,
Uh-huh.
being a key piece of evidence.
You're absolutely right. The presence of those extensively pneumatized bones, especially in the ilium, is a relatively rare trait among theropods. And guess what? It's a feature shared with Neovenator,
Oh.
a large-bodied predator from the early Cretaceous period.
So that shared characteristic could be a sign of a close evolutionary relationship.
Precisely. And there are other skeletal similarities that support this hypothesis.
Okay.
Features of the vertebrae and the femur also show some resemblance to those of neovenatoroids.
So it's starting to look like they're related then.
Well, it's one piece of a puzzle.
Okay.
But like you said, there's another hypothesis on the table.
Right. But then we have the tyrannosauroidea hypothesis.
Exactly.
What's the evidence pointing in that direction?
Here, the focus shifts to the skull,
Okay.
especially those of juvenile Megaraptor specimens.
All right.
Remember those long, slender snouts we talked about?
Yes.
Well, they bear a striking resemblance to the snouts of early tyrannosaurs.
Oh, wow.
And the shape of some of their teeth also shares similarities with those of tyrannosauroid ancestors.
So it's a bit of a tug of war.
It is a bit of a tug of war.
Skeletal similarities on one side,
Right.
skull and teeth features on the other.
Exactly.
It makes you wonder how paleontologists even begin to sort through all of this.
It's a challenge, for sure. Imagine trying to put together a puzzle with half the pieces missing.
Right.
And some of those pieces might even belong to different puzzles entirely.
Yeah.
But that's what makes paleontology so fascinating.
It is.
It's like a giant detective game.
Right.
And every discovery brings us closer to solving the mystery.
Okay, but let's not forget about that third hypothesis.
Okay.
The one that places Megaraptora at the base of Holdersauria.
Mm-hmm.
What's the thinking behind that one?
That hypothesis suggests that Megaraptora might represent a much earlier branch of the Coelurosaurian lineage.
Okay.
Before the split that led to groups like tyrannosauroids, ornithomimids, and maniraptorans.
So instead of being closely related to either neovenatoroids or tyrannosauroids,
Right.
they could represent a kind of missing link in the evolution of Coelurosaurs.
Exactly. It's a tantalizing possibility, and it highlights just how much we still don't know about theropod evolution.
Yeah.
The fossil record is full of gaps,
Right?
and Megaraptora might be filling in one of those crucial gaps.
It's amazing to think that these creatures could hold the key to understanding a whole branch of dinosaur evolution.
I know, it's really exciting.
It really puts things into perspective. But regardless of where they end up on the family tree,
Yeah.
there's no denying that Megaraptora were formidable predators.
Absolutely. We've talked about those huge claws and powerful forelimbs, but let's not forget about their speed and agility.
Right?
Those long legs and slender metatarsals suggest they were built for running,
Yeah.
perhaps chasing down prey over long distances.
I can just imagine them sprinting across the landscape, those huge claws glinting in the sunlight.
It must have been quite a sight.
It's a bit terrifying, but also incredibly awe-inspiring.
It is. It's a reminder that the world of dinosaurs was a place of intense competition and incredible adaptations.
Speaking of adaptations, we've touched on those air-filled bones.
Right.
And their potential link to bird-like respiration.
Mm-hmm.
But what else can those bones tell us about Megaraptora?
Well, they could also provide clues about their metabolism and growth rates.
Okay.
Remember, having a lighter skeleton would have required less energy to move around,
Right.
which could suggest a more active lifestyle.
So they weren't just fast, they were potentially quite energetic as well.
That's the idea. And those air-filled bones might have also helped regulate their body temperature.
Oh.
Especially important if they're living in warmer climates.
Okay, so we're getting this image of Megaraptor as these active, potentially warm-blooded predators
Yeah,
with incredible adaptations for hunting and survival.
right.
It's a far cry from the old image of lumbering, cold-blooded dinosaurs.
It is, and it speaks to the incredible diversity and complexity of dinosaur life.
Yeah,
But there's still so much we don't know.
right.
For example, we've talked about those massive claws as hunting tools, but could they have served other purposes?
That's a great question. Were they used in display or even combat between Megaraptora?
It's definitely a possibility. Some researchers believe those claws might have played a role in attracting mates or establishing dominance within a group.
Interesting.
Imagine two Megaraptora facing off claws raised in a territorial dispute.
Wow, that would be an incredible sight.
It would have been amazing to see.
It's like we're peering into a lost world,
Yeah,
trying to piece together the lives of these fascinating creatures.
we are. And the more we learn, the more intriguing they become.
Let's not forget about their surprisingly wide distribution.
Right.
We've mentioned their presence in South America, Asia, and Australia,
Yeah.
but what does that tell us about their evolutionary journey?
Well, it suggests they were incredibly adaptable, able to thrive in different environments and disperse over vast distances.
It does?
But how did they manage to spread across multiple continents?
Right. Were they migrating?
That's where the story gets even more interesting. Remember, during the time of Megaraptora, the Earth's continents were still in motion?
Right.
The supercontinent Pangaea had already broken apart, but land bridges still existed, connecting different land masses.
So those land bridges could have acted like prehistoric highways for Megaraptora,
Exactly.
allowing them to spread across the globe.
It's a reminder that the world we see today is just a snapshot in time.
Yeah.
The continents have shifted, climates have changed, and life has adapted and evolved in response.
It's mind-boggling to think about the scale of geological time and the forces that have shaped our planet.
It is.
But those land bridges might also hold clues to the origin of Megaraptora.
Mm-hmm.
Where did they first evolve?
Right.
And how do they manage to diversify into so many different species?
Those are questions that paleontologists are still trying to answer. Each new fossil discovery adds another piece to the puzzle,
Yeah.
but we're still a long way from having the complete picture.
It sounds like there's still so much to discover.
There is.
And that's what makes this deep dive so exciting. But before we get lost in the vastness of geological time,
Okay.
I think it's time to tackle the big question head-on, the classification debate.
All right, let's dive into the heart of the matter. Neovenatoroidae, tyrannosauroids, or something else entirely.
Right.
We'll examine the arguments, weigh the evidence, and see if we can shed some light on this paleontological puzzle.
Okay, we've covered a lot of ground in our deep dive into the world of Megaraptora.
We have.
We've explored their unique features, their potential lifestyles, and their surprisingly wide distribution.
Mm-hmm.
But now we're facing the ultimate challenge, figuring out where they fit in the grand scheme of theropod evolution.
You're right. This is where the real detective work begins. Remember, we've got two main hypotheses on the table.
Right.
Neovenatoridae and Tyrannosauroidea, each with its own set of compelling arguments.
And let's not forget that third hypothesis, placing them at the base of Coelurosauria,
Right.
which adds another layer of intrigue to the whole debate.
Exactly. It's a paleontological puzzle with multiple possible solutions.
Yeah.
And the evidence is often open to interpretation.
So let's break it down.
Okay.
Can you walk us through the arguments for each hypothesis?
Sure.
Starting with the Neovenatoridae camp?
Proponents of the Neovenatoroidae hypothesis point to a number of shared characteristics between Megaraptora and other members of this group,
Okay.
particularly Neovenator itself. One of the most compelling pieces of evidence is the presence of those extensively pneumatized bones.
Right.
Those air-filled spaces we see in the ilium and other parts of the skeleton.
Those air-filled bones seem to be a recurring theme in our discussion of Megaraptora.
They do.
And it's interesting that they're shared with Neovenator.
Yes.
Is that the only skeletal similarity they have in common?
Not at all. There are other features like the structure of the cervical vertebrae and the shape of the femur that also align with the Neovenatorid body plan.
Okay.
These shared characteristics suggest a possible evolutionary connection,
Right.
placing Megaraptora within the Neovenatory family.
Okay, so we've got the air-filled bones, the vertebrae, and the femur,
Yeah.
all pointing towards Neovenatoridae.
Right.
But what about the Tyrannosauroidea hypothesis?
Okay.
What makes some researchers think Megaraptora might be related to the tyrant lizard king himself?
Here, the focus shifts from the overall skeletal structure to more specific features, particularly in the skull and teeth. Remember those long, slender snouts that seemed a bit unusual for a large predator?
Yes, I do.
Well, it turns out that early tyrannosauroids had similar snout structures.
So it's like those long snouts are a family trait,
Mm-hmm.
passed down from tyrannosauroid ancestors to their Megaraptoran descendants.
That's the idea, and the similarities don't end there. The shape of the premaxillary teeth.
Okay.
Those teeth at the very front of the upper jaw also shows a close resemblance to those of early tyrannosauroids.
Okay, I'm starting to see how the evidence can be interpreted in different ways.
Right.
We've got skeletal similarities linking Megaraptora to Neovenatoroids, and skull and teeth features pointing towards Tyrannosauroid.
Exactly.
It's a real head-scratcher.
It is, and that's why the classification debate is so lively. Paleontologists are constantly analyzing new fossils, comparing anatomical features,
Right.
and using sophisticated statistical methods to try and reconstruct the evolutionary relationships between different groups of dinosaurs.
It sounds like there's a lot of room for debate and different interpretations of the evidence.
Absolutely, and that's what makes paleontology so exciting. It's not just about digging up bones.
Right.
It's about using those bones to piece together the history of life on Earth.
Now, before we get too lost in the debate between neovenatoria and tyrannosauria,
Okay.
let's circle back to that third hypothesis,
Yeah.
the one that places Megaraptor at the base of Coelurosauria.
Right.
Can you remind us what that one's all about?
Of course, this hypothesis, while less popular than the other two, proposes that Megaraptora might represent a very early branch of the Coelurosaurian lineage.
Okay.
Essentially, they could be a sort of missing link that predates the split between major Coelurosaurian groups,
Okay.
like tyrannosauroids, ornithomimids, and maniraptorans.
So instead of being closely related to either neovenatoroids or tyrannosauroid,
Right.
they might represent a more ancient and basal lineage within Coelurosauria.
Exactly. It's a fascinating possibility, and it highlights how much we still have to learn about the early evolution of these incredibly diverse theropod dinosaurs.
It makes you wonder what other surprises might be lurking in the fossil record just waiting to be discovered.
That's the beauty of paleontology. It's a field of endless possibilities where each new discovery has the potential to rewrite our understanding of the past.
It's a bit humbling, isn't it, to think that we're just scratching the surface of this vast and ancient history.
It is, and it's a reminder that we should always be open to new evidence, new interpretations, and new ways of thinking about the past.
Well, I think you've given our listener a lot to ponder today.
I hope so.
From those enigmatic claws to the ongoing debate about their classification,
Mm-hmm.
Megaraptor has certainly lived up to its reputation as a paleontological puzzle.
They have, and it's a puzzle that continues to fascinate and challenge paleontologists around the world.
So if you're intrigued by the world of Megaraptor, I encourage you to keep exploring.
Yeah.
Search for images, delve into the latest research, and maybe even try your hand at drawing your own reconstruction of these incredible creatures.
Who knows, maybe you'll be the one to uncover the next big clue that solves the mystery of Megaraptor's place in the grand scheme of dinosaur evolution.
And on that note, we'll wrap up our deep dive into this fascinating world. Thanks for joining us on this journey of discovery, and until next time, keep exploring the wonders of the prehistoric past.